Welcome to aminacademy.com. In physics, let us discuss about current, resistance and Ohm's law. First, we'll discuss about a current. An electric current is a flow of charged particles such as electron or ions moving through an electrical conductor or space. If a charged particles move through a conductor, is called a electric current. It is defined as the net rate of flow of electric charge through a surface. The moving particles are called charge carriers, which here charge carriers are electrons, which may be one of the several types of particles depending on the conductor. The electric circuit, the charge carriers are often electrons moving through the wire. The semiconductors, they are be electrons or holes. In an electrolyte, the charge carriers are ions, while in plasma and ionized gas, they are ions and electrons. In the International System of Units, SI units, electric current is expressed in units of ampere. The current I of electricity exists in a region when a net electric charge is transported from one point to another in the region. Suppose the charge is moving through a wire. If a charge Q is transported through a given cross-section of the wire in a time t, then the current through the wire is I equal to Q by T. I, the current equal to charge by time. Next one, what is battery? A battery is a device that converts chemical energy contained within the active material directly into electric energy by means of electrochemical oxidation, redox reactions. This type of reaction involves the transfer of electrons from one material to another via an electric current. Electric circuit. Here the current is flowing through the wire, as well as through electrolytic solutions. It is a source of electricity. If no internal energy losses occur in the battery, then the potential difference between its terminals is called electromotive force, EMF, of the battery. Unless otherwise stated, it will be assumed that the terminal potential difference of a battery is equal to its EMF. The unit of EMF, same as the unit of potential difference, that is volt. EMF, electromotive force, is equal, unit is volt. Next, what is resistance? An electrical resistance of a circuit is the ratio between the voltage applied to the current flowing through it. The unit of electrical resistance is ohms. Electric charge flows easily through some materials than others. Here, this is a battery, current flowing through current. This electron flow through the direction through the resistance. This is a circuit with resistance. Resistance R of the wire or other object is measured of the potential difference V that must be impressed across the object to cause a current of 1 ampere. To flow through it, R equal to V by I. Resistance R equal to voltage by I. It's Ohm's law. Current by voltage by current. This unit is ohms. The symbol is like. Next, we'll discuss about what is Ohm's law. Ohm's law states that electric current through a conductor between two points is directly proportional to its voltage. That is, current is directly proportional to its voltage. If current more, voltage more, current will be more. Introducing a constant of proportionality, that is a resistance, then one arrives at the three mathematical equations used to describe this relationship equal to V equal to IR, then I equal to V over R equal to V over I. This is important relation where I is the current through the conductor, V is the voltage measured across the conductor, and R is the resistance of the conductor. More specifically, Ohm's law states that R, this resistance or the relation is a constant independent of the current. That is, V is proportional to I, V is direct proportional to I, then V is equal to I R, where R is the constant of proportionality, that's called resistance. Here, voltage and current is direct proportion, this graph shows. Next, measurement of resistance by ammeter and voltmeter. Based on the value of resistance, the resistance are classified as low. Less than 1 ohm is called a low resistance. Medium is 1 ohm to 100 ohm is medium resistance, and higher than 100 kilo ohm. Here 1 ohm to 100 kilo ohm is the medium resistance, and more than 100 kilo ohm is called a high resistance. There are various methods used for measuring resistance used in their classification. Among these methods, this ammeter voltmeter method is one of the methods used to measure low and medium value of resistance. Let us see the measurement of resistance using the ammeter voltmeter method. Here in the circuit, resistance is connected here, the terminal, and other terminal is EMF, voltage battery is connected. Through this in series circuit, ammeter is measured, in parallel volt is connected. Now, the magnitude of the resistance can be measured by the different methods. One method is measure the voltage drop V across the resistance in a circuit with a voltmeter and the current I through the resistance with an ammeter. These using Ohm's law are equal to V over I. The measurement of V, respective measurement of A ammeter noted, and use this formula to measure the resistance R. Next one, terminal potential difference. Here, before that, further explanation of measurement of resistance by ammeter and voltmeter. A series circuit consists of a resistance to be measured, an ammeter, and a battery is used. The current is measured by the low resistance ammeter. The potential difference is measured by connecting the terminal of a high resistance voltmeter across the resistance. In a parallel with it, the resistance is computed by dividing the voltmeter reading by the ammeter reading according to the Ohm's law, that is R equal to V over I. If the exact value of the resistance is required, the resistance of the voltmeter and ammeter must be considered the part of the circuit. Next, what is terminal potential difference? The terminal potential difference of a cell is defined as the potential difference between the two electrodes of a cell in a closed circuit. The value of terminal potential difference of a cell is less than the EMF of the cell. That means EMF must be more in the circuit than consumed. When a current is drawn from the cell during the discharging of a cell. Look at here, V equal to E minus IR, potential difference minus IR. I into current through the circuit, and R is the resistance of the ammeter. Now, the terminal potential difference is depending the following things. When delivering current on charge, V equal, therefore, terminal voltage V equal EMF electromotive force minus IR. The when receiving current, here delivering current, when receiving current, V equal EMF plus IR. When no current exists, no current exists, that means we can say V equal IR. V equal EMF. There is no current, there is no IR. Next one, what is resistivity? Here, resistivity refers to the electrical resistance of a conductor of a particular unit cross-sectional area and unit's length. It is definitely a characteristic property of each material. Furthermore, experts can use resistivity for comparing different materials on the basis of their ability to conduct electricity. Look at here. Here, the current is, resistance is directly proportional to the length, and resistance is inversely proportional to cross-sectional area. That means length is more, length of the conductor is more, resistance is more. If cross-sectional area is more for the conductor, then resistance will be less. From this, we can use resistance is equal to rho L over A, where rho is the conductivity of the material. From this, rho is RA over L, that is ohms. This unit is ohms meter square by meter, that means ohm meter. Next, resistance varies with temperature. Of course, if resistance is more, temperature will be more. Here, the temperature depends of resistivity of a conductor is given by the relationship resistivity is equal to rho 0 plus 1 plus alpha t minus t0, where rho 0 are resistivity at temperatures T and T0 respectively. Then alpha T is the temperature coefficient of resistivity. In most conductors, the number of density of free electrons does not change with the temperature, but an increase in temperature increases the amplitude of vibration of lattice ions of the metal. Therefore, the collision of free electron with ions are almost while drifting towards the positive end of the conductor becomes more frequent, the resulting in a decrease in relaxation time. Thus, resistivity of a conductor increases with increase in temperature. Resistivity increases with increase in temperature. Next, what is conductivity? Electrical conductivity, it's just the reciprocal of resistivity. It is ability to material to pass an electric current through it. The SI unit of is Siemens per meter. In electrical conduction, there is a real movement of electrons towards the positive electrodes. Factors affecting electric conductivity: length of the material. Length is inversely proportional to the conductivity, and the area, with increase of the area of cross section, the conductivity of the material also increases. Impurity: when add the impurity to a material, its conductivity will decrease. Like some metals, added impurity gives less conductivity. Every material has its own electric conductivity. Silver has the highest conductivity, while lead is the least conductivity among the metals. Potential changes. What is potential changes? The potential difference across a resistors R through which a current I flows is by Ohm's law V equal to IR. The end of the resistor at which the current enters is the high potential end of the resistor. Current always flows downhill from high to low potential through a resistor. Therefore, VB minus VA means from high potential point B to the low potential point A, then subtraction both these potential changes. The potential terminal of a battery is always high potential terminal if internal resistance of the battery is negligible or small. If means the battery have internal resistance, if it is very low, then high potential terminal is the battery. Now, so far we discussed about different definition for in electricity, that is what is resistance, what is what is current, what is battery, what is the resistance, Ohm's law as well, the measurement of resistance by ammeter and voltmeter, as well the terminal potential difference and resistivity. Resistivity varies with temperature, and conductivity as well, potential changes. We have done. Please subscribe our YouTube channel.